you want me to take it out? I took a class in systems design and engineering, and in this class we designed this system intended to be a prototype energy storage system for a Remus 600 unmanned underwater vehicle. Lincoln Lab wanted us to extend the operating time. The Remus 600 currently is able to operate for approximately 3 days on lithium-ion batteries. Gasoline has an amazing energy density, which is several times more than batteries. The test that we're going to run is going to consist of having the vehicle surface, run the engine, and then dive. All right, let's start that engine up then.
Based on a command that the vehicle receives, it can start the engine, run the engine, and then shut down successfully, tell the vehicle to seal off all the valves for the snorkel and for the water intake, and then allow it to fill with water into a plenum, and then allows the vehicle to have enough neutral buoyancy that it can submerge.
It's been a bit stressful getting it in there. It's a complex system and a lot of things can happen, so you gotta have a flight checklist to go through. It has 2 end tanks. Each one of these tanks has a fuel bladder and a water bladder inside. As it uses up fuel, it replaces the fuel with an equal mass of water and air to make sure the entire system stays at a constant mass and therefore constant buoyancy. The engine right here turns a generator, which then produces electricity that can be sent to an auxiliary battery pack that the rest of the system can use. This here is the exhaust. We actually have check valves so we don't get backflow into the engine exhaust because we don't want to have seawater shooting up back into our engine exhaust. In here is the brains of the system. It is a PIC microcontroller. There's a whole variety of valves, pumps, and sensors that are used to make sure the system is maintained within its operable bounds. It is a proof of concept.